Hey, great.
Hi, you guys hear me well?
I don't know if you can hear me.
I can, yeah.
Okay, so you can hear the
Oh,
room.
now I can see me as well.
You can probably see the back of my head.
I can, yes. It's
Yeah.
a great head.
So, I don't know if you can make your font size any larger because otherwise people aren't going to see this very well.
Oh, you mean like this?
I'm going to make the picture a little smaller.
So how is this size? That should work, right?
At the moment, I can see the logo, that's all.
So can you hear me at all? Or?
I can hear you, but I think I'm going to have to turn the volume up a little.
Okay. Yeah. So I mean, I was just gonna have this, and then on my terminal, I'll just make sure that everything is appropriately large to see. Yeah, that should work.
I'm going to see if I can make you full screen here.
Anyway, you okay with that?
Yeah,
You okay with that?
I think we're okay. I need to be able to see if any of the other remote participants want to raise their hand.
Yeah,
Is that on this little panel?
it is, yeah. If you remove, sorry, open up the control panel again. And you can see sort of tab there.
Yeah.
So you've got one attendee. So
Yeah.
you just want to see who's joining.
No, I'd like to see if anybody from remote is trying to raise their hand to raise a question.
Well, it will pop up here. We'll just see this little.
Yeah.
Here.
Yeah.
They have raised their hand, we get like a little alert.
The trouble is, this is obscuring part of our display, so I wanted to put it away, really.
So you can drag it out, if you drag the attendees box out. Drag it. So you could leave that out on the screen and then close that. You know what I mean?
Nice.
And then you can close it. So you can drag that sort of like maybe in the bottom left corner or something, wherever you like.
That's neat. We'll start in a few minutes.
Okay.
Yeah, no worries.
We have to find the troops and drum them together.
It's nice to look at.
That's it. Here we go. Didn't actually be so.
A little bit.
That's why. That's why they went on now. Well, then, will you go back to the schools?
Oh, yeah, you want to put sort of.
Yeah.
We can,
Let's push it down as far as we can so there's too much of the screen. Put it in the corner. Fantastic.
well, I'll leave it here for you.
Yeah. Okay, 1 minute, I'll find people.
Back there.
Are we ready to start? Are we still waiting for some people, or?
Apparently those people who are sitting at the table. Yeah, it sounds that way. Internet.
It's Boston, let's make that
This is a bit of a first. We're going to have a presentation from somebody in a different country.
Sorry to keep him waiting.
I assumed you were part of some other group because you're sitting there having talking. Come on forward because we want to see the small writing on the screen. Right, well, thanks very much for coming along. We've got one remote participant online. Hello. And 6 people here in the room, and Baz presenting from, where are you, Baz?
I am currently in the Netherlands.
All right.
Netherlands.
Netherlands, okay, fantastic. Just to let you know, in case anybody hasn't been here in these premises before, if there's a fire alarm, please vacate the building because there's no planned fire alarm drill tonight. The toilets are sort of to the right from this door and around the corner, and that's where you also find a cloakroom. There will be more food at the end of this talk in about an hour and a bit. The next one is going to be on Wednesday, the 4th of March, and at the moment we haven't got anybody booked to do it, so if anybody would like to volunteer, got an interesting thing to talk about, please let me know. We've wasted enough time already, so I'm going to hand over to Buzz to tell us about Garden. And Buzz, if anybody from our remote participation group is wanting to ask a question or something, they have to raise their hand.
Okay, yeah. I'm assuming I'll get a notification of that when that happens.
I can see that here.
Okay.
See it, so I may have to relay the question to you. Okay.
Sure, sounds good. Just before we start, can you confirm that the current volume that I'm speaking at is okay? Can you hear me well?
Yes, good. Thank you. Okay.
Yeah, okay, good. Because I'm recovering from a cold, so I have a tendency to speak softer than I should right now. All right, then. Let me switch over to my slides right here. There we are. Can you just confirm you can see my screen?
Yeah, yes.
Okay, great. Well, first of all, again, thank you very much, Ima, for the invitation to speak to all of you tonight. As Ima said, my name is Bas Peters. I am the co-founder of a company called Garden. We're a 10-person startup based out of Berlin, though we do find ourselves in different parts of the world quite often. And essentially what we do is we build open source developer tooling for distributed systems. And it's that topic that I would like to talk to you about today. Now, I have a presentation plan of roughly half an hour or so, maybe 45 minutes. But after that, I'd like, of course, to entertain any questions that you might have. If along the way you have any questions or anything you'd like to clarify, please do just ask me. Like, let's keep this as interactive as possible. Since I'm assuming that most of you are fairly technical, I want to drill down into some things today and really get into the terminal and show some things in action. All right. So if anything is not clear along the way, then please don't hesitate to interrupt me, and we'll figure it out. All right then, so without further ado, today I'd like to talk to you about fast cloud-native development workflows with Garden. So let's just dissect that title a little bit that we're talking about today. So first of all, it might help to quickly tell you why we started this company and why we do the things that we do nowadays. So as you all know, when dealing with the development of simple applications, we have a single build configuration. We'll have some sort of local development setup. We'll have a unit test. If there's dependent services on this, we'll have an integration test as well. And then we'll need a dev staging pipeline configuration and maybe even a pipeline configuration to deploy this into production. Now, back in the day of the good old Java monolith that we all held so dear, this was the simple reality that we had to deal with. And though it was not very scalable, maybe from an operational perspective, it was very simple to develop. Nowadays, however, we see this trend of microservices emerge, and particularly, with technologies such as Kubernetes and Docker coming up, this very quickly starts becoming the reality. So we still need to define of every service how it's built, how it's tested, and how it's deployed. And this mess of configuration very often makes it fairly difficult to maintain an actual oversight of these. I can't see the actual room, but do many of you already have Kubernetes or Docker in your production environments right now?
Yes. Yeah, that makes
Yeah.
about half of us.
Okay, half of it. Okay, that's pretty good. I think by the end of the talk, I'll have convinced the other half not to do that. So let's see. So, and the same thing really goes for development workflows. So in a simple application, this is how we like to iterate on it. We make our change, we run and debug that particular change to the extent possible locally, right? We push our code and we deploy it. This is the ideal workflow that we can achieve with a monolith, because all of that testing context is on a local machine. But when we start splitting up an application into a lot of different subservices, as is often the case with a microservice architecture, our workflows quickly start to look like this, right? So instead of just, so when I make a small change in, say, one of the services that handles authentication, it is very possible that I accidentally break something in a different service that I wasn't even intending to, all right? And by having all of these services distributed like that, we quickly start to run into scenarios like these. And this is precisely why about 2 years ago, we started this project called Garden, which I'd like to demo you today. And what Garden does is, a lot of people call it different things, because it is a bit of a Swiss Army knife when it comes to microservice development. But the definition that I like the most is an iterative compiler for your whole backend. So I would like to show you how this works today. And I'm specifically targeting Kubernetes right now and containers, even though we support a bunch of other platforms as well. But because this is, the platform that most people are most likely to have experience with, that's the one we'll talk about first. Let's see. So the first notion that we want to share here is distributed configuration. I think a big problem that we have nowadays with microservice development is that we'll have services that are distributed across multiple repositories, very often run on different platforms. So you might have part of your services running in, say, Lambda, part of them are in Docker. Some of them may still be on VMs on-prem. And their configuration is as distributed as these things are. And their configuration should be as distributed as they are. Yet when it then comes to our pipelines, we tend to have these 2,000-3,000 line YAML files that make up a CI pipeline that are supposed to somehow hold this entire context together. And what we do with Garden, first of all, is that we actually make this configuration as distributed as your system is that you're intending to develop. So let's go over, and then the simple workflow that we want to bring back to distributed systems development is this: build, test, and deploy. So instead of having developers go into the very weeds of, say, how to build a Helm chart or how to build a container or an open fast function, right? And with Garden, we abstract away these simple verbs that developers know and also in that way trust. So let's see this in practice. So I want to just quickly go over how we reason about your systems in Garden, and afterwards we're going to actually show this in practice from an example project that I have set up. So as I said before, with Garden, your configuration is distributed, but at the very top we have what we call a project file, so a Garden project file. Now, this project file, in essence, contains two things. It contains a definition for your environments, and your environments can be a variety of things. So I'm assuming many of you are familiar with the typical development, staging, pre-prod, Q&A, prod, whatever you want to call it, environments. So that is what. So those are all, and those are analogous to environments in Garden. So you can specify different clusters that you might be wanting to deploy to as you go along the development flow. And second of all, you have sources. So with sources, you tell Garden where all the source code lives that you need to get your system up and running. So you point it to all of the different GitHub repos where all of your code lives, right? And Garden will then pull that together so you can work from one source of truth. And next up, Next up, we have modules. So a module in Garden is something you build, okay? Now a module can be a container, it can be a function, it can be a Helm chart, but it can also be something like a package, or it can be something like a Terraform module as well. So in Garden, we've built in this type system, this modular type system that allows you to reason between multiple types of platforms from the same development toolchain, okay? And within each of these modules, you define something we call a service. And a service is something that you deploy. So whereas a module is something you build, in the service part of that module, you define how the thing is deployed. For example, what sort of DNS endpoints does it need to expose? What ports does it need? What other modules need to be up and running before this service can actually. For example, I want my database to be up and running before I deploy, say, my API. And I want my API to be up and running before I deploy a front end or something like that, okay? And then last but not least, and this is a key differentiator in Garden and something we built in from the get-go, is the notion of testing. So every module not only defines of itself how it's built and deployed, but also how it itself is tested. So it can, for example, say, these are the unit tests that I may have. But I could also say, well, these are the integration tests that I have, and these are the other modules that I depend on, okay? Which brings me to my last point, and it's these dependencies. Now, if you think of the stack that you work with, right, it's pretty easy to map out some dependencies that you may have in there. And I mentioned some of these before. For example, you wanted to deploy an API an API only after a certain database is up and running. But with Garden, we take this one step further. So with each of these steps, building, testing, and deploying, you can also create dependencies between different steps, modules between each other. So you can say, only test this particular module when that database is done initializing, something like that. So what we're providing is basically a way to describe your stack in a distributed fashion, describe all of the build, test, and deploy steps of it, and also how they relate between each other. Okay. Now I understand that kind of viewing it from this way, it sounds a little bit dense, and I would agree to that too. But I wanted to just create a little bit of a picture before actually diving into code base and seeing how this works in practice. Are there any questions so far that I can answer?
Just a quick,
I'll see.
one very quick one. You talk
Yes,
about,
please.
I think the answer is a bit obvious, but with your integration testing, I assume that you are module version aware.
Yeah, it is. Yeah. So this is something the way we do versioning is actually pretty interesting, and it also we also use it to accelerate the development workflow as a result. But in a minute, I actually show this. I'll actually spin this entire thing up, and you'll be able to see that in practice, and I'll come back to it. Yep.
Going to ask to provide templates for each of these configuration files.
Excuse me. Sorry. Can you repeat the question?
Are there templates provided for each configuration file?
Yeah. So you know what? Actually, on that note, let's just jump into actual demo here, and I'll just show you all this in practice how it works. So let's look at an example project that I have here. All right. So and this is also what I'm going to do in this demo now is actually walk you through how I can take a feature from the change that I make locally in my code base through deployment to. Okay, just to set the context a little bit, this right here is an example application that I have quote unquote borrowed from Docker Compose to just kind of demonstrate the point. As you can see here, it contains 6 separate services. It contains 5 separate services in this repo. All right. I actually have another service that is not in this repository that lives in a separate Git repository that I can reference. Right. So Garden pulls that thing in for me dynamically. You can see that here. Now, before we get started, let's quickly look at what the application actually does, because it's pretty amazing. it lets you vote between two things. So you can vote tabs and spaces, and then it will show you that as a result on the other side. Okay, that's all it does, and it does this in a massively overcomplicated fashion. We have these two front ends here, the vote and the result. It will push that to a Redis queue. The API consumes it and it stores that in Postgres. Okay, and there's also a Java worker here, as you can see. By the way, is this too small or on the screen? I can't really see that.
It's good.
It's good. Okay, good. And we also have a J worker that I pull in from a different GitHub repo here, as you can see. Right, but let's quickly walk through those Garnet YAML files first, and also to your question about these templates. So let's see. So as I said before, every service describes itself. Okay, and it does this you do this by putting a single Garnet YAML file with each of your services. So these can be as simple as something like this. Let's see. This can be simple as something like this. So what I'm saying here is this is a module. It's of type Helm. Okay, so this calls the Helm plugin underneath, which I'll dive into in a little bit more detail later. I'm telling it like pull this chart for me, pass this value for me, done. Okay, as simple as it gets. But if you're developing your own services and not just pulling, say, charts or base images from the Docker registry, your Garnet YAML files are more likely to look like this. So here again, I'm saying this is a module. It's called vote. Okay, so it's at the front end I was using before to actually do my votes. This time it's of type container. Okay, so it just knows that it should look for a Docker file in the same in the same repository, in the same directory. I give it some information on how to hot reload, which is something we'll get back to in a little bit later. And here you can see these service definitions and these test definitions that we give Garden so it understands how to deploy and how to test this thing. So here I'm telling it that this is how you run it. These are the port source votes, the ingresses, and down here you see two separate tests. Now these are interesting to look at. For this particular service, I defined two test suites. First of all, we have a unit test suite, and then we have an integration test suite. Now the unit tests here you see are pretty simple, right? And what we actually do in Garden is that we actually run the tests within a running container. So you don't need to mark or stub anything like that. Pretend that services aren't there when they're not. You actually do this in a live environment, okay, which makes integration testing a lot simpler. And you can see here I've also defined an integration test, and I can make this test depend on another service. Now, whether this service is a Helm chart or a container or a service function doesn't matter. I can use Garden to kind of create this abstraction between in the form of a stack graph between these services like that. And so each of my services have a file like this, okay, where I've defined all of these things. And to answer your questions regarding these templates, there are templates, yes, we have those in the documentation sites. But as you can see, a lot of this language that's in here is actually pretty analogous to what you would have in a Kubernetes manifest. That's what we base a lot of this on from there. But the templates, so the complete YAML specifications for each of the module types, so for containers, for Helm charts, or Terraform modules, whatever it is, they're available within the documentation that we have. Great, so this is how, from a high perspective, you would configure Garden to actually spin up your stack, okay? But again, I would recommend everyone to just read the documentation because it makes no sense, to go through all this in too much detail. But what is interesting, of course, is to see how it actually works. So what I want to do now is I want to change these two options right here from tabs and spaces to something else, right? So as a developer, I'm charged with carrying out this particular task. The first thing I want to do is spin up a development environment so that I can actually see how how the changes that I intend to introduce would actually look in practice. Okay. Now, as you saw before, we've defined everything Garden needs to know to spin up a complete environment. So that's what we're going to do. I'm going to run the command Garden dev now. We have a whole bunch of commands that you can use. Let me just show you them. So you can, for example, choose to only build, only deploy, or only test your services. But with Garden dev, you're really doing everything in the kitchen sink. So we're entering what we call development mode for this particular stack. Now, when I initiate this command, what's happening here is that Garden is going to go through all of these Garden.yaml files, okay, take all of the steps required to go from a bunch of source files to a running system, and it's going to serialize those in the form of a graph, okay, and then it's going to execute those in that order, as you can see here. So I've now spun up a development environment of my stack that I've defined before. And all of this is happening in a remote Kubernetes cluster. So in my case, I've spun up a cluster on Google Cloud just prior to this talk, as you can see here. Just set the context for this. So all of this is happening in that remote cluster. I am not running Docker or Kubernetes on my machine at all. Okay, which is great because if you have a significant number of files, or say 2 Java services, you know, it's very normal that you cannot actually spin up the entirety of your stack because it's too much overhead. But now we have a complete development environment up and running in a remote cluster. So Garden comes with a dashboard as well to see this. Now here's a quick overview of all of my services that I have. And one of the handy things that I can do here, for example, is just look at the ingresses that I have. Make sure that everything is up and running. Well, okay, looks good to me. Now, what we want to do here is go ahead and change these 2 options here. We're going to change it to something else. So let's see what a development workflow with Garden actually looks like in practice. Now, when I entered the command Garden dev, as I told you guys, I entered what we call development mode. Now, what this does is it actually spins up my entire stack, as you can see here, and now it's waiting for code changes, right? So what Garden's now doing is it's watching my file system for changes to this particular code base, and then when those occur, it's going to pick up that change and automatically build, test, and deploy that change, as well as anything that depends on it. Okay, so let's look at that. You can actually see this here, how this would work. So these are all of those steps required to go from source files to a running system. Okay, so when I say change something in this API right here, it's going to trigger, it's going to not only execute this task, but also anything that depends on it and anything that depends on that. So let's just trigger that so you can see how it works. I'm going to go into this particular service here, add a comment, going to hit save, and Garden will pick up the change. It will synchronize this into my remote cluster, and then it's going to build, test, and deploy that service as well as anything that depends on it. So as you can see here, I'm actually rerunning this integration test because one of the upstream services changed. Now, the idea behind this is that as you develop, right, it's very common that you make a small change in a particular service that doesn't cause the unit test of that service to pass because everything is fine in that context, but you do end up breaking something minor in a different service. Sorry, please. Oh, sorry, I thought I misheard the question. So for example, say I have this API right here, and you can see that this vote service depends on it, right? Let's just break this integration test that we have down there. So I've defined an integration test here, and what it does, it's pretty simple. It just pings this API service and expects a 200 back. Right? So if I now instead make it return a 201, right, which might be a change reason, it will once again traverse the stack, but this time it will actually error out on the integration test when I come past it there. So this way, what we're trying to prevent here is one of the common problems that people have with, developing microservices. It's this very long feedback loop that you start getting once you start deploying systems of this size. It very often happens that you make a small change in a particular service, you push it to Git, everything looks fine, and then CI picks it up like, half an hour later, and it turns out that you broke something downstream. And with Garden, what we're doing is we're actually trying to bring all of this sort of testing back into that internal feedback loop that we used to have. Are there any questions about this so far?
Presumably you can deploy into on-premises as well.
Yeah, so this works against any Kubernetes cluster. So I just have Google Cloud because they gave it to us for free. Or in case any of you work for Google, because I like it a lot. Yes, this will work against anything. Actually, you can even see this here in my in the setup that I have. I have a local Kubernetes, so I could use something like Minikube, or in my case Docker for desktop or anything like that. And then I have this cluster right here lives in GKE, but this could be anywhere, including on-premise. Yeah, like that. Any more questions about this? Cool. Then we'll move on. I'll just quickly unbreak this here. All right, so now that I have this, let's go ahead and actually change those voting options, right? So smart me, I already know exactly where those here we go. So we have our options, tabs and spaces that we're going to change to something else. Let's make that like, I don't know, pizza and hot dogs, something like that. I'll quickly hit, I'll hit save here. And one of the things we can also do, by the way, going a bit of a tangent here, is we also have this thing called hot reloading built into Garden. I haven't enabled this right now, but it is available. What that does actually, this is great for front-end applications. Instead of rebuilding the container when something changes to its source files, it just goes straight into the running container and just swaps the files that change around. You don't have to reset the container. So that, kind of reduces the build time from 4 seconds to half a second, more or less. All right, so we've made our change. Let's see if that change is live. Well, yes, there we go. That's it in the running system. Well, this doesn't update automatically here, I see, but it should show us here now. Yeah, there we go. All right, cool. So now we have that. I'm happy with my changes. Well, go here. Great. Let's check out a branch. Let's add our changes to this here. Oop. Origin. And now we're just gonna push these things upstream. Fantastic. Okay, now I have pushed my changes to an upstream branch. Oh God, what is this? Oh, I'll do it later. Let's go in here. Oh, I didn't commit. I will push. Great. There we go. Fantastic. So I changed. This all looks good. I'm going to create a pull request. And now we're going to see the next thing. So because we have defined all of our testing and the way we can build everything in our code base already, you can also use Garden for CI, right? And that's what's happening here. So in my case, I'm using Circle CI, but it doesn't really matter what you use as long as it supports containers somehow. And even if it doesn't support containers, it will work, but just not quite as easily. So here I have set up I have set up Circle CI to do my testing for me. Okay, and as you can see here, Circle CI essentially runs the exact same commands as I was using to do my development, but in this case in CI. So as you can see here, it's just running Garden test. And what Garden test does is it just spins up my environment again. It runs only the test quickly, so it does the minimum amount of necessary to conduct all of the tests properly, and then it destroys the environment again. Okay. So in this case, now what we can do is we can actually use the same test in CI as we do during development. So we no longer have this divide that you would typically have if you have to sum up pieces together here. So we can see what the let's see if this is done executing it. Usually takes a while. Oh, that's great. Well, I'll just wait for this to update. Sorry, any questions so far about this?
You talk about integration, using it in integration. Now,
correct. Yeah.
The company I work with, we have a rather large stack, as you might say, a lot of different services. And one thing we tend to do is obviously make a small change, and we don't really want to necessarily retest every single component on the integration, at least not every single time. So other ways you've built into your capability to manage that so that you can do a bit more restrictive integration testing just to get some reasonable confidence before you're doing the full-blown works.
Certainly, yeah. So of course you can also choose to just test one particular service alone, right? You can run like Garden test, for example, Garden test API, something like that, and then this will only test that particular will only test that particular service for you. But also, this is a very common problem that people have, right? Running the exact, like if you think about your own CI setup, and you just kind of mentioned this before yourself, you typically have, say, 20 services and they have a whole bunch of integration tests. And if we want to test a small aspect of it, we have to test the entire thing, which is often unnecessary. And to have to wait 2-3 hours for a testing pipeline to finish is not uncommon, right? So one of the things that we do in Garden actually is, yes, of course, you can choose to only test a particular part of it. You can also choose to disable tests if you want to do that, or for example, to only test in certain environments or something like that. But actually, one of the things we do, and I forgot to mention this a little bit, is when I'm working in a remote cluster, every developer has their own private namespace, right? So everybody works, say, in their own private namespace. So if I'm working in a cluster and you're working in the same cluster, well, we're not really interacting with each other at all. But as you can see here, every build, deploy, and test that we do, we assign it a version, okay? And this version is so we hash every file within the module, and then we create a hashes of all those hashes. So we have what we call the master hash of that particular module. And this is also dependency aware, right? So if something changes upstream, then that hash will also change. Now, what we do is we actually, even though everybody works in their own private namespace, we do share the same cache between all the developers. So say if you've built something, then I've also built it, because if I wanted to deploy the exact same thing into my environment, I would just pull it from our common cache instead, like that. And the same thing applies for tests. So say that you during development have executed all of these integration tests already. When you then push it to CI, and CI picks it up and runs Garden test against the same cluster that you were developing in before, it will pull, say, 90% of the test results from cache already, because nothing has substantially changed beneath it, so it doesn't need to be retested again there. So this is a way that we actually try to, make people integration test more, because in our opinion, one of the reasons people don't do it enough is because, you're right, it takes a lot of time. Like if you have a substantial piece of infrastructure, it's just not possible to run it each time. But by caching intelligently like this, we, try to make that loop as fast as possible in that way.
Thank you.
Yeah, you're welcome. So yeah, so let's see. I hope that my circle CI is done here. It is still running. Well, whatever. So let's just go ahead and merge this here. So what's happening here in the background? Let's see. I mean, I just realized, like, I'm logged into my different GitHub accounts, so I can't actually see the circle CI executing. You just have to take my word for it. What's happening here in the background is that it's basically running this right here, right? But it's running it from it's running this command, but it's running that from CI. As you can see here, when I run that command, it's gonna execute all of those tests, but it's gonna hit the cache for all of my tests because I've already done them. Like this, it's going to give me the green check mark and then tear it down again, right? So then when I merge this pull request like that, what's going to happen is, in this case, I can also use Garden to deploy to a different environment altogether. So remember, this here was my production environment that I'd set up, as you can see here, right before it. But this, of course, now we actually need to merge this particular change. Now, usually I would rely on my trusty old Circle CI to do this for me, as you can see here. I just run a Garden deploy and then point that at my production environment. So this is the same code base that we're using, the same branch. But I pointed at my production environment to actually do an incremental rollout of this particular change. Now, as we see, unfortunately, Circle CI is not my best friend today. So I'll just do this manually here to run a Garden deploy. But this time, instead of my development environment, I pointed at my production environment. What this will now do is, again, take that same dependency graph awareness and redeploy and deploy only this one thing that changed. And then in a minute, we'll see this updated service in my production environment as well. There we go. As you can see, it's now deploying my thing. There we go. And if we now reload this thing here, there we go. That's it. I know, amazing, right? But it's just the point. But it's this is a small change, right? Of course, now that we made. But whether this is a 1,000-line pull request that we're doing, or whether it's a small string that we're changing, and I think what's important here is to note the workflow. We've enabled the developer to do everything from their terminal, essentially, right? And we have a single source of truth in this configuration here, as opposed to a separate configuration for CI. There's a separate configuration for testing infrastructure, for integration testing, et cetera, et cetera. And that is really what we're trying to achieve with this project, is to fold all of that together into what we call a single stack graph to make the development of microservices a lot easier than it is currently. So that was my presentation that I wanted to show you all today. Everything I've shown you here today is open source. You can go here on GitHub, garden-io/garden. That's where everything that I've shown you today, including this presentation, by the way, I mean the demo part of it, you can just go in there and spin it up yourself. The only thing you need is a Kubernetes cluster of some kind, whether that is whether that's Minikube on your machine, or whether it's a big cluster that you have on-prem. It doesn't really matter that much. And of course, you can also check out our website for a bit more information on some things that we provide. And of course, if you have any questions about this, you can always reach out to me directly through my email, which you can see down here, which is boss@garden.io. Okay, thank you very much. That's what I want to that's what I want to show you today. And of course, I'd be more than happy to take any questions that you have.
Thank you.
Any questions? Are there any questions from our online guest?
Can you run this on the Microsoft environment? The Windows environment?
Did you hear the question?
The question
No,
was about
sorry, I did.
environment.
Yeah.
Do you need to use Linux, or can you use Windows and Macintosh and so forth?
Right. So a good question. So we currently support Mac, Windows, and Linux. So you know, the Kubernetes cluster where it runs doesn't matter, right? We just talk to that API. In my case, I'm running this on Mac, as you might have seen, but we also have support for Windows, installation scripts for Linux. Everything is in the repo for you to check out. And this is, oh yeah, this is one of the nice things. So one of the big issues that, for example, we had when we even started the project is that I've always used Linux up till about 2 months ago when I dropped my ThinkPad from about 2 stories, which is a story for a different time. But you know, when you have an organization where multiple people, where everybody wants to work with Docker somehow, but uses different platforms, this can often be an issue in and of itself, right? If you work for any sort of larger corporation, Docker on Windows is typically not tolerated because it needs to run as administrator, right? By offloading all this heavy lifting to the cloud, you can remove that installation component from the laptop. So Garden as itself runs as a tiny container on your computer, and we have a small CLI in front of it that will work on any platform.
But a colleague of mine who's unfortunately not able to join us today, he's in a different time zone, did try out the sort of demonstration app that I think you showed us today.
Mm-hmm.
And he said he couldn't get it to run, but unfortunately I don't know what the problem was because he didn't share that.
Right.
How would you recommend getting to try this out? How would I start?
Right, yeah. So if you want to try this out, I would just recommend you go to our GitHub repo. So as you mentioned before, we have a whole bunch of example projects here, right? And I barely scratched the surface also of all of the plugins that we support and everything below that. So here we have a whole bunch of examples that you can look at. So it goes, for example, on, you know, how can you easily integrate TLS modules, or how would OpenFast work on this? What if I want to use Terraform with it, or Istio, or Canico, or anything like that? This right here is the vote example that I showed you today. And if you go in here, install Garden and run Garden dev, then this will, you know, spin up and work. If it doesn't work, so developing Garden, we spend about 60% of our time fixing Kubernetes bugs. Unfortunately, you know, Kubernetes is a moving target when you're trying to develop for it. So very often that's where the issues come from. However, if you do have any issues with getting that up and running, we have a Slack channel on the Kubernetes Slack there. It's called just #Garden, and we have an active community there of other people that are, you know, of course, contributing to this, working on this. I'll be more than happy to support you if there are any issues that you encounter along the way, because it's good feedback as well. If you're sure that it's a bug on our side, then of course please file an issue and we'll get it fixed as quickly as possible.
So you're handing out all this lovely free stuff. What's your business model?
I'm glad you asked. So we currently work on something called Garden Cloud. It's something that we're expecting to release a private alpha to some of private beta with some of our you know, our early customers in March. Now, Garden Cloud is a collection of services that use Garden as its open core to basically extend its functionality. So some of the things you can imagine, for example, that we're working on right now is something like secrets management, right? So a big issue that a lot of people have is how do you store sensitive data in containers, and how do you do that in VMs, and how do you do it during deployments? So that's one of the things that we're solving through a hosted platform that we're building around this. So Garden will always remain the open core and let's say the engine that's behind all of this. And then kind of, I would say comparable to how HashiCorp, for example, would work, right? You have these open source projects, and then we have these commercial extensions that you can get on top of it. If this is something that's of interest to you, so as I said, we're kind of working on the private beta right now. If it's something that's of interest to you to try, then please do shoot me an email. I'll be more than happy to get you onto that program. And some of the other things that we're looking to add there as well, for example, but this will be a little bit later into the year, is our own CI platform. So we think that a lot of the CI that we have nowadays is very bloated, and we're looking to add a CI platform that's expressly made for microservices, where you can also define the entire pipeline as part of this, as part of the service itself, as opposed to this separate configuration that needs to exist somewhere. And third of all, we're going to add a third-party plugin marketplace to it. So right now, what we do with Garden is detecting errors, and errors are pretty binary. It's like either this test passes or it doesn't, and that's useful in and of itself. But I want to take this whole thing one step further and make Garden able to actually detect regressions as well. So, for example, we're looking at ways that we can integrate something like load testing or vulnerability scanning or security scanning or penetration testing and things like that to the developer's workflow. So that's no longer the case of, somebody validating in the pull request stage that you have added a package that could be vulnerable, but instead we're making that part of the development workflow. So the second that you think of adding a package to it, that is actually marked with a CVE, you're notified of this immediately.
Thank you.
Okay, you're welcome.
Well, if there are no further questions, I'd like to thank Sebastian in the traditional manner.
Thank you very much.
I wish you a very pleasant evening.
Thank you very much. You guys have a great evening as well. Yeah, if you guys have any more questions, please don't hesitate to reach out. Thank you.
You had some Integra there. Yeah, BT, Integras.
Not for the Integra.
I work for this
Big company.
I work for this Integra. Right. So we had to come up with connectors.
Okay, so that
Yeah.